Hello and welcome back to the series on ion chromatography. This is episode 3, and here we're going to be talking about analyzing your data and exporting it off of the instrument. So let's get started.
All right, so congratulations on making it this far. Now let's get our data off of the IC, the moment we have all finally been waiting for. So obviously we're going to start by going into our file and finding our finished run. So I'm going to be using this one as an example because we have all of the data and there is no processing method for it. Now, so we can double click on any of these chromatograms that we have here and it'll open the data analysis software. So there are a lot of things here, but we are going to go through them one at a time. So this bar up here at the top pretty much determines everything that we see on our screen. The more things that you have selected up here, the more things that are going to clutter up your screen. The less you have selected, the more space you have to work with. So if I get rid of interactive results, all I can see is chromatogram. If I get rid of chromatogram, I can see nothing. So I usually always keep the chromatogram up, and I use these other things based on what I'm trying to do. The main things that we're going to be looking at are chromatogram, interactive results, calibration plot, and processing method. So the very first thing that we need to mess with is the processing method. Now this is one of the most difficult things to mess with. If you are using the exact same calibration curve as somebody else, and you are measuring the exact same things as somebody else, you can use their processing method. But if you have made a calibration curve that uses any different points from their processing method, do not use their processing method. You have to make your own. If you use their processing method and you change it to fit your calibration curve, you are messing up all of their data and you're changing their processing method in their files at the same time as you're changing it in your files. So in this case, I'm going to show you how to set up a brand new processing method because there was no processing method for our data. So I'm going to click down here. I'm just going to go basic quantitative, hit next. And then, yeah, I want it to apply to all of the injections in this sequence. I'm just going to call it, let's call it anions test. Okay. Finish. Now, more stuff just popped up. You'll see there's a lot of peaks in here that we just don't really care about, that we didn't really want, and that's going to be the case. Look at this. There's like 5 or 6 or 7 peaks all in there. The first thing we need to do is tell it that these are not peaks. And that is right here in these detection parameters. Now, there's a lot of different parameters that you can use. The most useful one I've found is minimum area, right? So I don't want it to be auto. I want to say anything with an area of less than, let's say, 0.01, I don't care about. That just got rid of a ton of peaks. It didn't really get rid of those, so I can change it from right here, right? Let's say 0.02. There's still some peaks over there that are getting recognized, so basically you just keep doing this until you've gotten rid of all of the peaks that you don't really want anywhere. Alright, so this is fine. This is definitely manageable. So now that we've got the detection parameter set and pretty much only the peaks that we like are selected, I'll show you how to mess with some of these weird things in a moment here. Now we have to start telling the instrument which of these peaks are which and what concentrations they are. So for that, we come down here to the component table. Now, knowing which peak is which can be really tricky at first, but the key is knowing which order these ions are going to come off of the column. You can Google it, or you can check the Dionex website, but I've done it a lot, so I have it memorized, and I know that the first one that's going to come off is going to be fluorine. And we're going to select its retention time. It's this peak, right? So it's about 3.5 minutes. And look, now it recognizes that that peak is fluoride. So the next one is going to be chloride. And that one is right around 5.7 minutes. And so on and so forth, right? So let's just really quickly plug in the rest of these. Okay, so we have all of our components selected and we have them at the correct times. Now, a useful tool up here, because sometimes these peaks do move a tiny bit, is going to be this. It's peak windows. So let me find it. Layout. We want peak windows to show up. So now this is how we can widen those ranges, and we want to widen them. See how it didn't actually get our highest peak? We want to widen it to our highest concentration and make sure that it goes from like base to base of our highest concentration. Now that is adjusting it right here, right? That's adjusting this window every time I change it. And this is just to make sure that over the range of concentrations that we use in our samples and that we used in our calibration curves, it is going to detect all of the peaks. All right, so that's pretty good. So another tip, you can see here that this peak actually looks a little strange. This is what's called tailing. So the peak is kind of shifting to the left. This is because this is my highest calibration curve. It means that the concentration is getting right about to its highest limit, its upper limit, and it's starting to overload the column. So when your peaks get too big, you might get some huge peak that encompasses all of these, which is why we stay under 100 parts per million. It looks like I forgot to do phosphate. All right. So we can see, all of our peaks are selected right here, and it is identifying them all pretty well. We got some weird stuff going on, but we will talk about that in a second. So actually, we're going to talk about that right now. So we have set up our processing method pretty well. Now we need to make sure that all of these peaks are selected accurately. So what I'm about to do, you actually need to do this with every single one of your samples. There's a good chance that the Chromeleon software is going to do it pretty well, but sometimes it'll select your peaks like this, and that's just not an accurate peak area, right? So here's some useful tools that you can use for fixing this. We're going to go delete peak. We're going to delete that peak. We're going to zoom in on it and select it from the bottom to bottom. That is an accurate peak representation, and this is also an easier way to set your peak windows. Full size. So we can look at all of them now. Just make sure that they're all pretty good. That one's good, and I did that phosphate in the wrong spot, so this should be there. So for the most part, most of these other ones look good. We can look at some of our actual peaks. So like, see, this fluoride peak was actually too small. So there's multiple peaks here around the fluoride, and we'll talk about something like that later. Chances are one of these are fluoride and one of them or two of them are small organics. But like I said, we'll talk about that later. So now that we know that our calibration plot looks good and all of our peaks are selected accurately, it is time to tell it what our concentrations are. So we have to go back to our data. Remember this thing? And now that we've assigned a processing method, see how our processing method is here, we now have levels for our calibration curve. These need to be levels 1 through 5. So there's 5 levels because I had 5 points in my calibration curve. And now when I go back here, see all of my components have these levels. This is where I put all of the concentrations in. So I'm going to do this with phosphate because phosphate is what I'm interested here. But just know that the process is exactly the same for all of the components that you're interested in. I know that my concentrations were 1, 5, 25, 50, and 100. Now, I can look at my calibration plot. And something's wrong. That's what's wrong. Okay, this is why we do this. Calibration point 3 was not recognized as phosphate. So it's for some reason thinks that this tiny thing. So let's delete that peak. Now it thinks it's phosphate. And now my phosphate calibration plot is linear. That's actually kind of good that that happened. Surprised me, caught me off guard. But now you can see that your calibration plot is straight. I thought I made my calibration curve wrong for a second. Okay. So yeah, if it's straight, you know that your samples are going to be measured accurately. If you go to processing here, something that I like to do generally is I like to force it through the origin, or at least compute it with the origin, because 0, 0 should be a point on your calibration curve. Now when I hit save, it's going to save all of my, it's going to save that, all the changes that I made to my processing method and everything. Once you've got all of your values in here and you know that all of your calibration points are selected correctly, see, like this one isn't still. So I should have gone through all of these and made sure that they were all right. So this is how we do it. Loads of different little techniques that you can use. A lot of your skills are just going to come from messing around with it. You're going to have to play around in this software a lot before it actually all makes sense. That one looks good. That one looks good. All right, so now they all look good. And my calibration plot is very linear. So we're done with our processing method, at least for phosphate. And now we can open up interactive results. If I go to summary here, it's going to show me all of my samples. So my injection name, it's going to show me the area, and this amount is calculated using this calibration curve. So I don't actually need that open anymore. And we can see that these are the concentrations of phosphate in all of my samples. Now I should technically go through each one of these and, make sure that phosphate was selected. This is obviously not a peak. It just thinks that it is because there's nothing else here. So I want to delete that peak because there's nothing there, right? If I auto scale this, maybe there's something. There's a little bit of phosphate there. Looks like the baseline is still a little bit messed up. So I want to move this baseline upwards so that it's flat. And then let's auto scale that again and make sure. Yeah. So that's something about what my peak should look like. Now this is such a small concentration, 0.0055 parts per million, that yeah, sometimes your peaks are going to look a little funky, especially with phosphate. Phosphate is an incredibly hard ion to measure. Chloride and these smaller ones are actually much easier. And cations are just overall easier than anions, so you will almost have no problems with cations normally. But you should be doing this for each and every one of your samples. You can see a lot of mine are messed up, so I'll have to go through them and actually select that phosphate peak, make sure that it actually looks right. That was a DI water, don't worry about it. But yeah, so once you've done that and you've gone through all of your samples, it is as easy as just copying this, Control C or right click. Looks like right click copy paste doesn't work, but Control C and Control V, you can copy this entire table and just paste it in Excel, or just copy this individual column. What I like to do is copy this column and paste it into Excel, and then just copy the amounts. So I'll just copy this one and paste it into Excel, and then go to sulfate here and copy this column and paste it in Excel and go to nitrate. And then I've got all of my injections and their amounts one after the other right next to each other.
So here's an example of an Excel file that I made for somebody else. So this is that sample column. He wanted chloride, nitrate, and sulfate, so I only copied those three columns. When you want to analyze your data, you can come in here and just kind of delete out the DI waters, and then you're just left with all of your sample names and all of your concentrations in milligrams per liter. And I like to make one tab for anions and one for cations as well.
So yeah, once you've done that, you've got all of your samples and all of your data in Excel, and you are ready to go. So that's basically how you do everything in a really basic manner. But there are a ton of different ways that we can analyze our samples with this process. And like I said earlier, the easiest way is to practice and play around with it. So don't play around in somebody else's files because you could mess up their processing method. Play around in your own. And ideally with your own processing method, something that you made yourself. But I'll talk about some of the most useful tools right now. Like I said earlier, by far the most useful tool is deleting peaks and making new peaks. So that's not a peak right there. I don't want it. That was just a flat line. I don't want that there, so I deleted it. And my fluoride peak, right? Auto scale signal. Here's another thing. Auto scaling. You see how this is probably some sort of organic, some sort of organic material. They usually come off right around fluoride, organic acids. And we don't want that. We don't want that involved in our peaks. So here is another really useful tool. It's called shaping shoulder. So I'm going to look at where this is about linear, and I'm going to right click on it, and I'm going to hit shape shoulder. And it cuts out that extra peak because they're a little bit overlapped. And this happens a lot with fluoride. Obviously, it overlaps with a lot of these organics. But it's also useful for a lot of other things like phosphate. So very useful tool, that one. Another really useful tool is the peak overlay method, right? So suppose I've got these two peaks here and I don't know which one is actually fluoride. So I can pin this one and overlay it with my calibration plot. So right here, they're stacked one on top of each other. But if I come up here to layout, I can actually make them go right on top of one another. I can change the offsets, and we can really clearly see that, okay, this is the fluoride, and this is the fluoride peak. So this has to be the organic. This is a really useful tool for peak checking, making sure that your peak is actually what you think it is. You should always do this if you're ever worried that something is not the same chemical as was in your calibration standard. So all you really need to do is put all of the values in for your calibration points. So like if I wanted all of this data, I would need to fill all of this out before I take all my data off, copy and paste it into Excel, and if you ever get stuck, just ask someone who's familiar with the IC to help you. It's really easy to ruin other people's data, instrument methods, and processing methods if you start clicking around in their stuff without knowing what you're doing. And sometimes even if you're clicking around in your own stuff, you can mess up a lot of things on the instrument. So be really careful and make sure that you've double checked with people who know what they're doing before you start messing around with the IC too much. So thanks for listening and good luck.